Hi, everyone. Welcome to section 8.1. Let's talk about chapter 8. Chapter 8 is hypotheses testing. So let's get started. Let's begin with talking about what are the basics of hypotheses testing. So in this section, we're going to look at definitions. We're going to look at what is hypotheses testing and what can we do with that. So let's get started. In this section, we will present key components for formal hypotheses test. In this section, we're going to, in general, we're going to apply hypotheses test involving proportions. So this is what we're going to look at. We're going to look at hypotheses with dealing with proportions, means, standard deviations, or variances. Remember that this helps us kind of give a conclusion about a conclusion or statement. Remember that we looked here in chapter 7 when we were looking at the difference between a confidence interval and hypotheses testing. Hypotheses testing is definitely used to kind of give us an inference of what's going to happen. Definition: a hypothesis in statistic is a claim or statement about a property of a population. So we are going to be doing a claim or a statement. A hypothesis test, however, is the procedure. So there's a difference. One thing is a claim or a statement. The other thing is the procedure for testing a claim about a property of a population. So we are going to first do a claim, and then we are going to be testing the claim. Let's start by looking at the first example. The majority of a consumer are not comfortable with drone deliveries. 1,009 consumers were asked if they were comfortable by having drones deliver their purchases. And 54%, or 545 out of 1,009, said no. We're going to use P to denote the proportion of consumers that are not comfortable with drone delivery. The majority, so this is keyword, the majority of the claim is equivalent to the proportion greater than half. So the population proportion P is greater than half. The expression P greater than 0.5 is a symbolic form of the original claim. So based on this information, we know that 54% are not comfortable. That means that that is greater than 0.5. That would be the symbolic form for the claim. So the majority of the consumers are not comfortable with the drone delivery. What's the big picture? The big picture is that we have a claim. This is a hypothesis, a claim, that the population proportion P is such that P is greater than 0.5 among 1,009 consumers. How do we need to get a significantly high number who are not comfortable with the drone delivery? Well, first we begin with the 506. The 506 is more than, it's just barely more than half. So that's clearly not significantly high. Okay. A result of 1,006 or 99.7 is significantly high. But what about 546 or 54%? Well, what we want to do is we want to test if 54% is significantly high or significantly low. And the method that helps us do that is hypotheses testing. So for the first one, we identified that 50% is not considered significantly high, but 1,006 is definitely a high value. So what we're going to do is look at the proportion, population proportion, to determine whether it's significantly high or significantly low. One of the ways to actually identify whether we can do such hypotheses testing is we're going to be using technology. So instead of a TI-83, TI-84, we're going to be using StatDisk. So StatDisk is the website that I showed you. So if we go over here and we're going to go into StatDisk, So let's remove this and let's put StatDisk. And if we go into analysis, you're going to look at hypotheses testing and then proportion of one sample. If we look at over here, we're going to look at something called alternative hypotheses significance. The claim proportion here was 0.5. We're going to look at the sample size, 1006. The number of successes was 500. What was it? Let's go back. It was 506, I believe. Yeah. In this case, it was 545. So this is 545. The alternative hypotheses, what was it? In here, we're going to talk about the alternative hypotheses. So here it was when P is greater than 0.5. So we're going to be using StatDisk, and I'll show you how to do that. We can also use the TI-83, TI-84, and to do that, you're going to go to second calc. Second. If I project here, if we use calculate 84 to find one prob C test, so you're going to go into stat. Let me remove this. So in order for us to find it, we're going to go to stat. So on our calculator, we're going to select stat directly, and then we're going to move into test. And then we're going to hit on one prob Z test. And that will be the hypothesis testing. So we are going to be plugging in P hat and N, and then we're going to look at Z, the Z score, and P. So we're going to look at our test statistic Z, our critical value, and our P value. When we're using technology, we're going to look at something called the P value. And that P value will help us and focus on understanding how hypothesis testing procedure works and learn associated terminology only when the results from technology make sense. So sometimes it doesn't. So what we're going to do, we're going to look at hypothesis tests or tests of significance. Remember that in section 4.1, we use probability to determine whether something's significantly high or significantly low. This chapter formalizes those concepts in an unified procedure that is often used in many different fields of application. So significance is very important when using hypothesis testing. We'll begin by defining what is a null hypothesis. A null hypothesis is denoted by H of 0. This is the notation when I ask for a null hypothesis. H of 0 is the statement of which the value of your population is equal to some claim. So whenever I ask for a null, you're always going to have an equality. So it always will contain an equality symbol. An alternative hypothesis. What is an alternative hypothesis? Alternative hypotheses can be defined as H of 1, H of A, or letter H of big A. So normally I'm going to be defining it as H of A in this class. Is the statement that the parameter has somehow different from the null hypothesis. So it will always either have a less than, a greater than, or not equal to. So for the example that we have, if we go back to StatDisk, our alternative hypothesis is the less than. The population is Let me go back to the notes right here. So we're assuming, if we look at the example, P is greater than 0.5. So the proportion would be something greater than what's being claimed. So then here, when we hit evaluate here, we would get some values. That would tell us the sample statistic. This is using StatDisk. Using in our alternative hypotheses on the top, the significance level, the claim proportion, the sample size, and the number of successes. That would be for the alternative hypotheses because it's less than, greater than, or not equal to. So what is the procedure for the hypotheses test? The first thing you want to do is you want to make sure you identify the claim. You identify the claim. Then you give it a symbolic form. And then you identify who's H of 0, or sorry, what is H of 1, what is H of 0, or what is the null hypothesis, what is H of 1, what is the significance level, if alpha is 0.05 or alpha is 0.01. That's very common. And then you need to identify what type of test statistic are we using. Are we going to use it using the p-value method or the critical value method? So there's two ways. If you're using the p-value method, you need to find what the value of p is, and then you will conclude either you will reject the null or you will fail to reject the null. So you will reject the null if the p-value is less than or equal to alpha. You will fail to reject if the p-value is actually greater than alpha. The other way is to use a critical value method, which is using the test statistic and the critical values. So either you're going to use z-score as your critical value, or t-score, or even a chi-score. So it depends. So you're going to be rejecting the null if the test statistic is in the critical region. So that one, you're going to actually have to use the z-score, the t-score, and then see if it's in the shaded region or outside the region. You're going to be restating the decision in non-technical terms. So this will actually be a final sentence. So your final conclusion will be a statement. Okay, so you're going to finalize with a statement. So let's look at confidence interval method. Construct a confidence interval method with a confidence level selected as table A-1. So this is the table A-1 using confidence level for a confidence interval. So depending on the significance level of the hypotheses, we either are going to do a two-tailed test or a one-tailed test. Because a confidence interval estimate of a population parameter contains likely values of that parameter, we reject the claim that the population parameter has a value that is not included in the confidence interval. So based on a confidence interval, we are going to determine if we will reject a claim or not. Most of the time, we are not going to be using this table. So for this section, we are not going to be using confidence level or in confidence intervals. All we're going to be doing is we're going to use our null hypotheses and our alternative hypotheses. So let's begin by use the original claim to create a null hypothesis, H of 0, and the alternative. So we want to identify the claim to be tested and express it in a symbolic form. We're going to give the symbolic form that must be true, such that the original claim is false. We are going to consider the two symbolic expressions, H of 0 and, H of 1 and H of 0. H of 1 is the alternative, H of 0 is the null. So remember, the alternative hypotheses will use less than, greater than, or not equal to. That must be the symbol. And H of 0 will always be the equality. So let's go back to this example. Given the claim that the majority of the consumers were uncomfortable with the drone delivery, we can apply steps 1, 2, and 3. So here we have it. We identify the claim to be using a proportion P, the probability, that P is greater than half of the people. So what we're going to do is that we are going to create the symbolic form to be true. So if the original claim is P is greater than 0.05, then what would make it false? Well, you're going to reverse it. That means that P is less than or equal to 0.5 must be true. Then we are going to identify our, so remember, our null hypothesis is always equality. So we're going to let P equal 0.5. That would be our null hypotheses. Alternative hypotheses will be, so we used P greater than 0.5, so we are going to use the opposite. P less than or equal to 0.5. So the alternative hypotheses would be P is less than or equal to 0.5. The significance level, alpha, in the hypotheses test, in this case, we would allow alpha equal P. So when we're rejecting the null, when the null is true. The significance level alpha for a hypothesis test is the probability used as a cutoff for determining the evidence constitutes significance against the null. So here, alpha can be 0.05, 0.01, and 0.10, where 0.05 is the most common. So based on the significance level, we are going to get different answers. And then the last step is to identify what test statistic is relevant. So for us, we're either going to have a normal, a t, or a chi-squared. Well, that depends on the following parameters. So let's look at that. So if we're given a population proportion P, the sampling distribution will be a normal distribution. These are the requirements. N times P should be greater than or equal to 5. N times Q should be greater than or equal to 5. And the test statistic is actually going to be a z-score. The z, where it's going to be p hat minus p divided by the square root of p times q over the square root of n. If your parameter is a mean, then we're going to use a t distribution, a student t. Remember, there's 2 steps for the mean. If sigma is not known, you're going to use a student t. If sigma is known, you're going to use a normal z distribution. You're either going to have a t-score or a z-score. And if you have a standard deviation, you're going to have a chi-square distribution, where your chi-score test statistic is going to be n minus 1 times s squared over sigma squared.